Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 8, 2025, about 2 days ago. The headline result is a scalable curriculum reinforcement learning recipe that turns short problems into long chains and lifts tough benchmark accuracy by up to 2.06 times. The paper is titled H1, Bootstrapping LLMs to Reason Over Longer Horizons via Reinforcement Learning, and the implications for model training are quite significant. In short, the method composes atomic tasks, trains with outcome-only rewards under a staged curriculum, transfers to harder math and long context tests, and even shows theory that cuts sample complexity from exponential to polynomial. The previous segment introduced the method at a high level. Figure 1 shows the overall idea and the headline gains. The left panel illustrates a staged curriculum that links outputs of short problems to inputs of the next, which scales reinforcement learning without saturating. The middle graph reports higher pass at K across the board, with a clear gap even at large K, suggesting the model learns new reasoning paths. The right chart shows transfer to harder tests like AIME 2024, roughly doubling accuracy from about 5 to about 11. Well, Figure 1 showed the setup and headline gains. Figure 2 shows bar charts by problem horizon, comparing the instruct baseline, standard reinforcement learning at Horizon 1, and the curriculum up to Horizon 5. Accuracy jumps at Horizon 2 from about 35% to about 59%, and at Horizon 3 to about 36%. The biggest lifts arrive at longer chains, about 2.8 times at Horizon 4 and about 2.9 times at Horizon 5, which signals that curriculum prevents saturation. So the previous figure highlighted big gains at longer chains. Table 1 presents the exact accuracies by horizon, which makes the pattern unmistakable. The instruct baseline drops from about 83 at L1 to 3.6 at L5, showing how long chains hurt. Equal compute baselines barely help beyond L1 because they lack useful signal. The curriculum at Len 5H1 lifts results to 86 at L1, 59 at L2, 36 at L3, 18.8 at L4, and 9.8 at L5, and even nudges L7 and L8 upward. So Table 1 quantified horizon-wise gains. Figure 3 shows pass at K accuracy versus sampling budget for unseen lengths 6, 7, and the curriculum up to length 5 dominates across K, even at K about 128. The standard length 1 reinforcement learning curve tracks the instruct baseline, which indicates capability bounds. The large gap at high K signals genuinely new reasoning paths, not just better sampling. The left, middle, and right panels correspond to lengths 6, 7, and 8. Alright, the previous figure showed strong pass at K gains on unseen lengths. Table 2 reports how those skills transferred to harder math. The curriculum on composed GSM-8K lifts math 500 to about 69, symbolic P1 to about 73, and symbolic P2 to about 52, which clearly beats standard reinforcement learning. AIME rises sharply, with AIME 2025 near 3.0 and AIME 2024 about 10.5, roughly twice the instruct baseline. Alright, 2 takeaways stand out: composing short problems into long chains, then training with outcome-only rewards under a staged curriculum, reliably lifts long horizon reasoning, and even doubles accuracy on tough math. The matching theory shows training becomes polynomial in Horizon, not exponential. The broader implication is scalable reasoning training without step supervision. That is it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.